Hello. In the last video, we introduced polynomials and started to talk about their characteristics that make them unique. And two of the things that we pointed to last time were the end behavior and their behaviors at 0. And that's what this video is going to focus on. So first is figuring out what the ends of a polynomial are going to do. And that's based on the degree and the value of that leading coefficient. So we have four cases. If the degree is even and a is greater than 0, both ends are going to point up, just like one of our favorite even functions, x squared. Now, if the degree is even and a is negative, the ends are both going to point down. Again, just like our favorite negative even function, negative x squared. Now, if the degree is odd and a is positive, they're going to point in opposite directions. And it's going to look like the most basic function to an odd power, x. And then if the degree is odd and a is negative, the ends will again point in different directions. The left one will be pointing up and the right one will be pointing down, just like negative x. So it's very easy to figure out what the end behavior is if you compare it to one of the four basic functions, either x and negative x, or x squared and negative x squared. For zeros, we can figure out what the behavior is based on that multiplicity, what the exponent of the 0 is. So if the multiplicity is odd, it's going to cross through at that point. So for example, if I have f of x equal to x, I could even write it like this so we can see that 0 is definitely one of my zeros of the function. And we can see how it crosses through the x-axis at 0. So with an even multiplicity, it's going to just touch at that point. Our basic example, x squared, or x minus 0 squared. At its 0, it's going to touch it and then go away. It's not going to cross through. It will just touch that point and then continue back in the other direction. Now, obviously, this is the most basic example. If I have something like this function, that means it's still going to cross through at 3. It'll still cross through at 1. Now, practicing what we learned about end behavior, the degree of this polynomial would be adding up all of my multiplicities. So it's degree 4. And I know because this is even, it'll look like x squared. And then these are my only two zeros, so it's only allowed to go through the x-axis at these points. And you can see now if I connect all of this, I have a pretty good idea of what the function looks like. And that's how we connect the end behaviors and the multiplicities in order to figure out what the general shape of the function is.